Okay, in this video we're going to dig into a little bit of the syntax of JavaScript. We're going to discuss expressions and variables and functions to start with. Okay, so last time we discussed some of the history of JavaScript, and we discussed that there is a server-side JavaScript engine called Node.js. And if I want to execute Node.js in interactive mode, I just type the command node in my terminal, and we see we are at the Node.js interactive mode command prompt, right? So this isn't the same as my Linux command prompt here. We're in a different mode, right? So here we can execute JavaScript. So to the 8th, it's 256, to the 10th, 1024, all sorts of JavaScript, anything we want, we can execute in this interactive mode. Okay, so that's not always useful. Sometimes we have complicated scripts and we don't want to type everything out manually. So what we're going to do is create a script that allows us to modify it, and then we can run this repeatedly. So we can make little changes, run the script again, make a few changes, run the script again, right? So we'll start with the simple hello world. That's the classic example for most programming languages. So I'm using my Atom text editor. It's a nice text editor, and I'm on my desktop, so I just created a file, helloworld.js. Now the .js is the extension for JavaScript files. So the classic example is to just print out hello world. So in JavaScript, the print statement, the way to print something to the terminal is with the console.log statement. Okay, console.log. And in JavaScript, every time you finish a line, you need the semicolon. Now, most browsers and even Node.js are very forgiving, so if you leave that off, a lot of times everything will work fine. And a lot of modern developers intentionally leave the semicolons off in almost all of their code. But there are situations in JavaScript where a semicolon is required, so it is my recommendation that you always use the semicolons. That way you won't have to remember when they're always required and when they aren't. Okay, so as we discussed last time, JavaScript is an evolving language. It's been around since 1995, and there have been lots and lots and lots of changes. And in order to remain backwards compatible, a lot of the old changes still work in JavaScript, even though they're not ideal. They're not necessarily recommended. So there's this sort of concept of JavaScript, the good parts, and JavaScript, the bad parts. So I'm going to try to inform you of JavaScript, the good parts. Some of the newer features that have been added to JavaScript allow for syntax changes like no semicolons and things like that, but in general I still think semicolons are important. So all that to say, this is one line of JavaScript, and we want to print out hello world. Okay, now there's a few things going on. First, we have this console, right? This is an identifier. Identifiers you can think of as variable names. Okay, so an identifier identifies some piece of data in memory, right? In this case, this identifier is holding an object. So how do I know that's an object? Because we are using the dot operator afterwards. So if I have a particular object, there are properties associated with that object. To access those properties, I use the dot operator. Okay, so I have an object, and I'm accessing a property on that object, and that property is also an identifier. So log, this is an identifier, and it's identifying, you can think of it like a variable, it's identifying some piece of data in memory. In this case, log, the thing in memory, is holding a function, right? Functions are actions, right? We can think of data as nouns and functions as verbs, right? Functions do things, right? So this is a function, and to execute a function, you have to have left and right parentheses. Okay, so there, you're going to execute some function, but we want to pass in information into this function. So this function is going to do something, but it's going to do something different depending on what data we pass into it. Okay, so we're going to pass in the text, hello, comma, space, world, exclamation point. Now this text is known as a string. This is a type of data that is just a string of individual characters. Okay. Now, if we had numbers in here like 22, these are two individual characters. It's not the number 22. It's just two characters that happen to have the same image as 22, right? Two specific characters back to back versus the numeric value of 22. So this is string data. When you see anything in double quotes or single quotes, that's string data, a string of characters. All right, and then at the end of our line we have the semicolon. So just to recap, we have an identifier, that's an object. We're accessing a property with the dot operator. So it's accessing a property on that object. That property is the identifier log. Log is holding a function. To call a function, we have to have the left and right parentheses. And if we want to pass data into that function, we have to provide it inside of those parentheses. Okay? And then we have a semicolon. So we can save that file. See that little blue dot in Atom? If I hit Control S, it saves the file. So we have on our desktop now this hello world file. So back to our terminal, we're still in Node. So we need to type .exit. Now we're back to the desktop, ls, and there's my file, helloworld.js. So I can run this with the node command. I type node space and then my file name, helloworld.js. Okay, and now we see this is what the console.log function does. It prints out whatever text you pass it as a string. Notice the quotes aren't there anymore. These individual characters are the data. HELLO, comma, space, WORLD, exclamation point. That is the data that was passed in. The quotation marks just indicate what type of data this is, and that's character data. Okay, so we can log this to the terminal. Now we can also do this in interactive mode, right? I can just type node, and we're at the interactive mode, and I can just copy this. Control C, and then I'm on Linux, so to paste into my terminal is Control Shift V, right? Now if I do this in interactive mode, there's a couple of downsides. One being if I have a whole bunch of code, I would have to type all of that code in every single time in interactive mode, which is kind of a pain. The other is if I'm using some kind of text editor, we get this nice colorization, right? So we see that the object has a particular color, the property on the object, if it's a function or if it's a piece of data, it might be colorized differently. We see string data is in green. So there's a lot of colorization that can help you understand what's going on in the code versus looking at it like this. It all kind of runs together because it's just one color. But that's okay, we can still use interactive mode. And when we do this, we see console.log, hello world. This is the result of the function, right? So it's printing out to the console, but then we see undefined here. Now why do we see that? That's because in interactive mode, it parses every statement as if it were an expression. Okay, so if this is an expression, the result of this expression is undefined. So undefined, what does that mean? It means there's no value defined. So when you run a function, functions can return values. Okay? Console.log, however, does not return a value. When a function does not return a value, the default value to be returned is undefined. Okay? So that just means when we ran console.log, there was no result returned. All right, so what's an example of a function that returns a result? Okay, so we can use the built-in math object. So math is an object built into JavaScript. It's a global object, so you could just reference math. It does have to have a capital letter. And I can say math.min. And we see this is a function. We see down there the interactive mode is telling us that that's a function. And to execute a function, I use left and right parentheses. So the min function allows us to pass in any number of values. And we can just type in some stuff here. And there's my semicolon. And it returns the minimum value. Okay? So here, we didn't print anything to the console, right? But this function was evaluated as an expression. Since this function returns a value, then that is the result of the expression. Okay, so we could, if I execute this again, I could add to this expression. I could say plus 100, right, and press enter. So this is a more complicated expression. So functions can be part of expressions if they return values. So this has to be executed first, right? So anytime you have a function, sort of think of those parentheses as grouping symbols. The function has to execute before anything else. So we don't know what to add to 100 until this function executes and returns some value. So the minimum value out of this set is 34. So that's going to be the return value. So once this function executes, essentially everything that's highlighted here is replaced by the return value. And we have a situation like this, 34 plus 100. So this is an expression. Now we've evaluated part of the expression. Now we're down to 2 operands and 1 operator, and then we evaluate that, and then we get 134. Okay, so this is sort of how expressions are evaluated, but it's important to note that functions can return values, and when they do return a value, you can join them in expressions, right? Other expressions, arithmetic expressions, but also they don't have to return numbers, right? They could return string values, Boolean data, other objects, arrays, all sorts of different things, okay? But they can return a value. But they don't have to. So like console.log does not return any value. So again, even if I were to say console.log, what do I want to log out? I want to log out the result of math.min, and I'm calling a function here, and we'll use the same values, 56, 89, and 34. So what is this? This looks a little bit daunting, right? What we can do is we can add some spaces here to kind of let us know what's going on. And here we see console.log is a function, right? But we're passing it this information. Well, this is what's called an argument to that function. Any data you supply to a function is called an argument. But this argument happens to be an expression, right? It's a function call. So this expression must get evaluated to a single value before the larger function executes, because we don't know what to pass this function until we have a value, right? So we have to call this function, which will return a value, and then the result of this function is going to be something like 34. And now we've got a value here that we can pass in as the argument to this console.log, right? And so here is what console.log actually logged to the console, and undefined is the result of this expression, because remember, console.log does not return any value. Okay, so we'll do that again, but we'll pass in math.min, and we'll pass in all of these arguments to math.min. 89, there we go. Okay, so math.min, however, it's a similar situation as console.log. Math is an object. We're accessing a property on it with the dot operator, and min is an identifier that holds a function, right? But here we are passing in 3 pieces of information. So we have 3 arguments here. Now, in the Linux command line, you have arguments to commands. So here we have node, that's the command, and then hello world.js is the argument. It's the additional data supplied to it, right? And on the in Linux, you separate arguments with white space. So node is the command, and then anything separated by white space is the arguments you're sending to the command. In JavaScript, you separate arguments with commas. You don't have to have a space here. You can run them all together, but I like to put spaces there. It's common practice because it's a little bit easier to read. Okay, so here we have 3 arguments, and that will execute, return a value, and that one single value is our only argument to the console.log function. Okay, so we can take a look at this. Let's copy this, and we'll add that here. Okay, now notice when I run this, we're not going to see the results of each one of these expressions. Okay, each statement here, console.log returns a value. When we do this in interactive mode, we see the result of every single expression you type. Okay, now there is a result being generated, but we're not storing it anywhere, and we're not doing anything with it, so we don't see it. So that is one difference between interactive mode and then running the file directly. So let's exit out of interactive mode, and we will run node and then our hello world program. Okay, so all we see now is the results of the console.log function calls, right? So if we didn't have these console.log function calls, right, let's remove those real quick. And we just had their arguments. I'm going to save this now. Right? And now I run this. We have no result. That's because console.log is the thing that prints things out to the terminal. Okay, so that's very important. So I'm going to hit Control-Z and just go back to, oh, I can't because I closed the file. So we'll just add console.log back here. Caps lock is on. And sorry about that. There is no capital there on console. So the casing does matter. There are times when there is a capital letter and times when there are not. So for example, math, that is a capital M, but console is not. So you'll just have to remember when to use capitals and when not to. Right, so that's a simple hello world example. It shows you the idea of expressions, and it's important to know that expressions always evaluate to a value, right? And then function calls. Now one thing I want to stress as well, you have these expressions, a lot of times you want to store that result in a variable. It makes sense sometimes. So like if I wanted to print out the number of bits in a byte, right? So I can use console.log, and I'm going to pass in two different arguments. This first argument, actually I'm going to leave off the space there and just have a colon, and then the next item I'm going to put in here is how many bits are in a byte. There's 8 bits in a byte. Then I can type in console.log how many bytes in a kilobyte, right? So a kilobyte is the binary version of what is more commonly referred to as a kilobyte, but it's binary. So a kilobyte is 2 to the 10th power. So there are 2 to the 10th bytes in a kilobyte, right? So I can add these console.log statements. Now notice what happens. We have 2 arguments, right? So console.log is automatically going to put a space between printing these 2 things. And also note that I don't have to convert that to a string. The console.log will automatically convert this integer data into string data. So there's a difference between 8, like this, which is character data, and then integer data. With integer data we can do arithmetic, we can do math, right? With character data we can't. We have to convert the character data into integer data if we want to do any math. So that's just a little bit about data types, and we're going to discuss that in depth in future lectures. All right, so let's run this and see where we're at. All right, bits in a byte, or 8 bits in a byte, and bytes in a kilobyte, and there's 1024. So that's 2 to the 10th. All right, so how many bits are in a kilobyte? All right, so I can say console.log how many bits in a kilobyte. Should be lowercase. All right. Well, bits in a kilobyte. If there are 1024 bytes in a kilobyte, and there are 8 bits in each byte, I would just multiply this by 8, right? So I could say something like 8 times 2 to the 10th. Right? And order of operations should work there. And so this will be 1024 times 8. We can run that. Right, so 8,192. But notice one thing I had to do is I had to retype this value for 8, and I had to retype this expression. Even though I already calculated this once, I had to do it again. Right? And as a computer scientist, I'm lazy, and I never want to do the same thing twice. All right, so one of the things we need to do here is think about storing values. So if we have an expression that calculates some value, we might want to store it in a variable. So we're going to introduce ways to store data. So the let keyword is what you're going to be using most to create a variable. So we're going to call this bits in byte. Okay, so I'm creating a variable. Bits in a byte is just an identifier. Just like console is an identifier, it identifies data in memory. So identifiers can start with alphabetical characters or an underscore, and they can contain numbers, but they can't start with a number. If I start this with a number, JavaScript thinks that this is an integer. Okay, so we can't start identifiers with a number, but they can contain numbers. So I can have a 9 in my identifier name. But this is just a name. Think of it like a variable, right? It is a variable. So let allows me to declare a variable, right? If I just do that, I've declared a variable that's undefined. Or I can set a value to it immediately. Okay, so let bits in a byte equal 8. So there are 8 bits in a byte. So now instead of having this 8 literal here, now you might hear the term data literals. This is the integer 8, and it's a literal because I'm literally typing it into my code, right? It's not a variable, it's a literal. So here instead I'm going to use the variable that is storing this value of 8. And here this is an 8 literal. This is a 56 literal. It's an integer literal. This is a string literal. It's string data that I've literally typed into my code, right? Now it's different than a variable. So we're storing the value associated with that literal in this variable. So here we need bits in a byte. Okay, and this dotted underline is just my editor. It tells me if I've misspelled something, and it doesn't know that word in the dictionary, so it's underlining that for me. But ignore that. So bits in a byte, there are 8, and then we might want another variable, bytes in a kilobyte. Okay, so that's the unit for kilobyte. And that is going to be 2 to the 10th. Alright, and so now here I guess I can just say bytes in a kilobyte. Alright. Now why is that useful? Specifically for this next line. Now I don't have to do these calculations again. Granted, this one isn't a real calculation, it's a string literal, so it's about as simple of an expression as you can have. But I did have to do a calculation here. And as a computer science, I never want to waste programming resources. I don't want to waste computational cycles. So if I had to calculate this again, it wouldn't be the end of the world. It's a very small expression, but in general, I'm always trying to look to save computational cycles. So if I use this variable instead of recalculating this, I'm saving CPU cycles. So here I can say this is going to be bits in a byte times bytes in a kilobyte. Now notice the style of these variables. This is called camel casing. You start out in lowercase, and for each word you capitalize that word. Right? That's called camel case. Alright, but we see here we have console.log, and now we have this expression. So how many arguments are we passing into console.log? We're passing in this argument, which is string data, and we're passing in this expression. This expression must evaluate to a single value before it can actually be passed into this bigger function, this larger function, right? So this must be evaluated first. It must come down to one single value, and ultimately it's just going to multiply 8 times 1024. So we're going to get the same output here, but the way we've done things is a little bit different. We've created variables, we're storing data in those variables, and we're reusing some of our past calculations in order to save computer processing cycles. Alright, so we can run this again, and we get the same result, right? And it's important to name your variables in a way that lets you know what they are, right? I could just name this A and name this B, right? But then I'm not sure what these variables are supposed to represent. If I just see the variable name, I don't know what it's supposed to represent. So if I name the variables appropriately, I know what it's supposed to be. This is bits in a byte and bytes in a kilobyte. Okay, so the let keyword allows you to define variables. And with the let keyword, I can change the value. So I set bytes in a kilobyte to, I might have that as 10 to the third power, which that's actually a kilobyte. And so I might want to change that to a kilobyte. And I can say that's to the 10th power. Right, that's 1024. 10 to the third power is 1000, and that's a kilobyte. But here I can change the value stored in the variable. That's only because I used the let keyword. So we can run this again to verify that that's correct. Right, and everything works as it should. All right, but specifically for things like this, where we're defining a variable to hold a value that's really set in stone. The bits in a byte, that never changes. That's always 8. So I really, if I declare this properly, I really don't want this to ever be changeable. So I might want to make this const. So this is the other way to define a variable. When you define a variable with const, you always want to set a value immediately. With let, you don't have to set a value initially, and you can change the value. With const, this can never change. So if we go back to bytes in a kilobyte, that should never really change if I declare it properly to begin with. So here, I didn't declare the right value, so I changed it with a variable that was declared with let. All right, but realistically, I want to declare this properly and use the const variable type. Okay, so why is this important? It's because this value should never change. It's always going to be 10 to the second. The number of bytes in a kilobyte never changes. We don't want to change that and accidentally break other parts of our program that are using this variable, right? So we can save this and we'll run it and we'll see that const does indeed work just like any other variable. But if I tried to change this value, let's go down here, I'm going to copy and paste bytes in a kilobyte, and I try to change this, we'll say, let's incorrectly say this is like 64 or something, right? Now I'm going to see an error here, assignment to constant variable, okay? That's because other parts of my program could be using this, and I know that this value should never, ever, ever change because it's constant. Bytes in a kilobyte is always the same. If somebody accidentally changes it, then this error shows up. That's telling them you should never change this variable. So that's the difference between let and const. In most cases, you're going to be using let, and if in doubt, go ahead and use let. But const is used when you are setting a value, but you never want that value to change once you've set it the first time. Okay. One other thing you might see as you're reading articles, reading different things in about JavaScript, and you'll see some code. A lot of times they'll use the var keyword. So var is another way to define variables, but it's an old style way. So var a equals 7, something like that. So there were var has been around the longest. Let and const are relatively new. I think they're 5 or 6 years old, but var has been around forever. So there's a lot of old legacy code on the internet that uses var, but there were some problems with the var variable declaration, and we'll get into why that is in future lectures. But I just wanted to mention that you can declare variables like this, but we shouldn't. I'm mainly bringing this up because you'll see code on the internet as you're looking up JavaScript articles. You'll see var a lot, and that's fine. Just replace it with let. Anytime you see a var and you're typing the code out, replace it with let, and that's the newer style way of declaring a variable. Okay, so that should be enough for now. That gets us through expressions, function calls. Arguments in function calls are expressions as well, and they always evaluate down to one value, right? And we talked about variables, which allow us to store the results of expressions. Naming variables, we usually want to use camel casing. We want to have good names for our variables, right? Explain what the variable is so that way I don't have to look through a whole bunch of code to figure out what's stored in that value. In the case of bits in a byte, I know that value. I know what that is. That should be 8 because there's 8 bits in a byte. Right, so name things appropriately, and then declaring variables with let if you want to change the value of the variable later, or const if it's going to be constant throughout the duration of your program. All right, and then we talked a little bit about efficiency as well. We want to save compute cycles when possible, right? So if I only have to calculate something once, I might as well store that in a variable and save the CPU some calculation, right? This case is not really saving much, so it's not really important in these smaller cases. But if you were running a function that did millions or billions of calculations, that would take a whole lot of processing power, and you'd want to save the result one time. You wouldn't want to keep calling the function when you wanted that result. Okay, so efficiency is something that comes up a lot in computer science, and we're going to be dealing with that a lot. Not just computational efficiency, but also memory efficiency, storage, how big the data is that I'm storing, right? So that sort of thing. So we'll go into all of that later, but that should be enough for this particular lecture.